Hi there. Our topic today is partial fractions. We're going to learn how to split a single fraction into simpler fractions. Now let's go straight to it. I'm sure we still remember partial fractions. I'm sure you still remember how to add simple fractions of this form. For example, 3 over x plus 1 plus 2 over x minus 2. When you add these two fractions, this is what you get. The LCM is x. The LCM of the denominators is x plus 1 times x minus 2. X plus 1 times x minus 2 divided by x plus 1 is x minus 2. And we multiply that by the numerator of the first fraction, which is 3 times x minus 2 plus 2 times this LCM divided by x minus 2 is x plus 1, and we multiply that by the numerator. That's 2 times x plus 1. And then we simplify, we open the brackets at the numerator. That's 3x minus 6 plus 2x plus 2 all over x plus 1 times x minus 2. And that's the same as 3x plus 2x is 5x, minus 6 plus 2 is minus 4. So that's the same as 5x minus 4 divided by x plus 1 times x minus 2. Now this is the single fraction. This is a single fraction which splits into these two simpler fractions. So the process of splitting single fractions into simpler fractions is what the concept of partial fractions is about. So what we'll be doing here is splitting single fractions into simpler fractions. Now, so that's it. Now let's go. To start with, we're going to learn the different types of fraction. Now, and by the way, that single fraction that is split into simpler fractions is called a compound fraction, and the simpler fractions into which it is split are called partial fractions. So let's see the different types of fraction. A, fractions with non-repeated linear factors at the denominator. So the kind of factor at the denominator of that fraction has a lot to do with how we are going to resolve it into partial fractions at the denominator. You see what we mean by non-repeated. For example, if we say x plus 1 and it's just raised to power 1, we say it's non-repeated. But if it's x plus 1, that's a linear factor. And that's a linear factor, but if its power is greater than 1, then we say it is repeated. We'll explain that further as we take examples. The second is fractions with non-linear factors that are not repeated. Non-linear factors that are not repeated. That means non-linear and also not repeated linear factors. C, fractions with repeated fractions with repeated factors, linear or non-linear. Here the factors at the denominator are repeated factors, linear or not, or non-linear, and they could be linear or non-linear factors. Now to the last one, improper fractions. Improper fractions. So I'm going to start with the first. Like I said, a repeated factor is one which has a power and exponent greater than 1. If I say, for example, 2x squared plus 5x plus 3, this is a quadratic factor. If it has a power greater than 1, then we say it's a repeated factor. If I say x squared plus 5, this is also a quadratic factor and it's non-factorizable. So if it has a power greater than 1, then we say it's a non-factorizable. Anyway, it's a non-linear repeated factor. If it can be factorized, then we factorize it into linear factors and say, if it can be factorized, we factorize it. But here, it is non-factorizable. So if it has a power greater than 1, we say it's a non-linear repeated factor. So we're going to see more of that in the examples. So I'm taking an example on the first type. Let's call that example 1. Resolve into partial fractions. And the fractions here are those with non-repeated linear factors at the denominator into partial fractions. So we're dealing with the first type of fraction. Resolve into partial fractions. Roman figure 1. Roman figure 1, that's, let's take 3x plus 2 divided by x plus 2 times x minus 5. And the second is 1 minus 2x divided by x plus 5 times x minus 3. So let's go straight to the solution. The first question is 3x plus 2 divided by x plus 2 times x minus 5. And this is how to do that. We can see that these factors are linear and they are not repeated because their powers are 1. X plus 2 is the same as x plus 2 raised to power 1. X minus 5 is the same as x minus 5 raised to power 1. So they are not repeated linear factors. And this is what you do to resolve into partial fractions. You say that is a all over x plus 2 plus b all over x minus 5. And then we find the LCM of the denominators, which is x plus 2 times x minus 5. So that means a times x minus 5 plus b times x plus 2. Now we can see that these two fractions are similar. I can see that 3x plus 2 all over x plus 2 times x minus 5 is similar to a times, is equivalent to a times x minus 5 plus b times x plus 2 divided by x plus 2 times x minus 5. That simply means the numerators are also equivalent. So that means 3x plus 2 is equal to a times x minus 5 plus b times x plus 2. Let me call this equation 1. So I want to put x equals 5 in equation 1, putting x equals 5 in 1. I'm doing that to eliminate a. If I put x equals 5 in equation 1, this will become 0, and I'll be left with putting x equals 5 in equation 1. That means 3 times 5 plus 2 is equal to b times 5 plus 2. Because a times 5 minus 5 will become a times 0, which is 0. So I will be left with only b in that equation. And that means 3 times 5 is 15 plus 2, 17. 17 equals 7b. And that means b is equal to 17 over 7. Now, what else can I put in equation 1 to get b? If I put x equals minus 2 in 1, if I put x equals minus 2 in 1, I'll get a. I'm thinking of what I can substitute in equation 1 to get a now, and that's minus 2. So putting x equals minus 2 in 1. We are doing that to eliminate b. Putting x equals minus 2 in 1, 3 times minus 2 plus 5. 3 times minus 2 plus 2 rather. 3 times minus 2 plus 2 is equal to a into brackets minus 2 minus 5. And this will be out. Minus 2 plus 2 is 0. So when you multiply that by b, you get 0. So I'll be left with 3 times minus 2 plus 2 equals a times minus 2 minus 5. And that's minus 6 plus 2, which is minus 4, equals 3 times minus 2 is minus 6 plus 2 is minus 4, equals minus 7a. And that means a equals, when you divide both sides by minus 7, a equals 4 over 7. Therefore, 3x plus 2 all over x plus 2 times x minus 5 is equal to a, which is 4 over 7. I'll not write it this way being the first time. That's 4 over 7 divided by x plus 2 plus 17 over 7 divided by x minus 5. And of course, that's the same as 4 all over 7 times x plus 2 plus 17 all over 7 times x minus 5. And that's it. So if you care, add these two fractions and see if you get what we resolved into partial fractions. That's what you're going to get if you do the right thing. Now let's go to example 2. Example 2 says, let's see that resolve 1 minus 2x all over x plus 5 times x minus 3 into partial fractions. In the same vein, that's the same as a over x plus 5 plus b over x minus 3, which simply means the LCM is x plus 5 times x minus 3. And then we have a times x minus 3 plus b times x plus 5 at the numerator. So since the denominators are the same, that means the numerators are also equivalent. 1 minus 2x equals a times x minus 3 plus b times x plus 5. And we can do, let's call that equation 1, and do the same thing we did in example 1. Putting x equals 3. If I put x equals 3 in equation 1, I'll be able to eliminate a and find b. That means 1 minus 2 times 3 is equal to 8. Sorry, this will be gone. A will be gone if I do that, and I'll be left with b times 3 plus 5. And that means 1 minus 2 times 3 is 6. 1 minus 6 is minus 5 equals 8b. And that means b equals minus 5 over 8. That's dividing both sides by 8. Now in the same fashion, we are putting x equals minus 5. Put x equals minus 5 in 1 just to eliminate b and find a. That means 1 minus 2 times minus 5 equals a times minus 5 minus 3. B will be out when we do that. If you put x equals minus 5 in equation 1, b will be out and you'll be left with a. So that's 1 minus 2 times minus 5 equals a times minus 5 minus 3, which is the same, which means 1 plus 10, and that's 11 equals minus 8a. And a is therefore minus 11 over 8 if you divide both sides by minus 8. So that simply means 1 minus 2x all over x plus 3, x plus 5 rather, times x minus 3, x plus 5 times x minus 3 equals a, which is minus 11 over 8. That's supposed to be a over x plus 5, so it's the same as minus 11 over 8 times, or maybe I should write it the way I wrote it the first time, minus 11 all over 8 divided by x plus 5 plus b, which is minus 5 over 8 divided by x minus 3. And this is the same as minus 11 over 8 times x plus 5, and then minus 5 over 8 times x minus 3. Move that back a little. Over 8 times x minus 3. And that's the final answer, simply. So that's it, very, very simply. Just go through that, and I'm sure you understand and enjoy it. Thank you very much, and see you in the next. Bye-bye.